All right, let's go bowling. We have this lovely bowling ball here that was donated to the department a couple of years back. And we simply drill a hole in it and put an eye bolt here so that you can turn it into a lovely little pendulum like this. And the thing that's cool about a pendulum is that it's continually converting potential energy into kinetic energy and then vice versa, back and forth. Now if I take this bowling ball and I put it on my chin like this, I'm going to be a little bit of a daredevil here, and I'm going to close my eyes and just hope that it doesn't bust my chin. Trusting in the law of conservation of mechanical energy, here goes. Yeah, hit my shield. There we go. And no damage done to my chin. The reason that works is conservation of mechanical energy. Here we have the initial energy is equal to the final energy, and we can write the mechanical energy in terms of kinetic and potential. Here are the initial values, here are the final values. Now kinetic energy is just 1/2 mv squared. Potential energy is mgy, where y is the height of the bowling ball from the ground. It's not the distance horizontally, it's the vertical distance. And so what I was doing there is I was starting with no initial velocity, and I was ending with no final velocity, and as a result, just divide both sides by mg and I get that the initial height is equal to the final height. And that's why it came to rest right up against my chin. Now, what happens if one of those quantities, one of those velocities is no longer zero? What happens if I give it a push at the very beginning? So I'm going to start like this and I'm going to give it a shove. What's going to happen? Well, looking at this expression over here, I see that VI is no longer equal to 0, and as a result, the final height is going to be larger than it was for the last case. So let's give it a shot here. I'm going to push and get out of the way. I've done this enough times that I know I need to get out of the way.